Continuing on with sampling distribution, we've talked about sampling distribution of just counts. We've talked about sampling distribution proportions, and now we're going to do another sampling distribution here. So let's get into it. We want to know how tall are high school seniors in Michigan, and then attached a couple pages down, we have all the heights of all 50 high school seniors at a small high school in the Upper Peninsula. So we see our dot plot here. And what this is a population distribution. This is everything, everyone. So each dot here represents one student's height. So we can see it. It looks pretty normally distributed. And that'll come in handy later. So right now you can make a guess what the mean of all 50 students is. Make another guess at the standard deviation of all 50 students. Remember, the mean is the average height, and the standard deviation is how far away someone's height typically varies from that mean. So since this is the whole population, this is all 50 students of this high school, we can figure out the population mean and the population standard deviation. And we do have variables for each of these. So we're going to go over to our equation editor, and we want to know the population mean, which is mu. And in this case, our population mean is 168.98 centimeters. And then our population standard deviation, which is sigma, is 9.606. We're going to put those right next to their meanings. Population mean is mu, and population standard deviation is sigma. So in class, we are going to have you guys choose random numbers between 1 and 50. We can use the random number generator on the calculator, on the phone. There's a website, random.org, that we'll probably use in class to get random numbers between 1 and 50. And then you're going to get a sample of 5, and average them and calculate the mean. We do this a bunch of times, and we're going to put them all together just like we did last class and create a dot plot below. So we'll do that in class. I'll make another video to show what my class came up with. But I want to talk about what all the dots are going to represent. So in this dot plot, when it's created, each dot will represent the mean, the average height of a sample of 5 high school seniors from this Upper Peninsula High School, UP Upper Peninsula in Michigan. Remember, StatsMedic, which gives us our notes, they're based out of Michigan. So we'll be able to compare this dot plot to the one that we are given of the population and make some comparisons, talking about the shape, center, and spread. So we'll just make those generalizations here. Our shape both will appear to look approximately normal. And what we've learned from that is that a sampling distribution, this whole section, sampling distribution, taken from a normal population distribution will have a normal shape. So when we start with a normal distribution like we did right here, and we take a sample of any number from that sampling distribution, from that population distribution, which was normal, then the resulting sampling distribution dot plot will be normal as well. We can also discuss the center. The center will appear to be the same. And so what we learn from that is that the mean, let's make sure we're typing right here. The mean of our sampling distribution of means, and we're going to change that to X bar real quick to talk about our sample mean, will equal our population mean. So, which is going to be the same as what we started with at 168.96. So that won't change. But what we're going to find out in our final comparison is that the spread, we already talked about shape, didn't we? The spread of the distribution, we'll see that the sampling distribution is kind of squeezed together, and we can call that and say that's less variable. And so what we learn from that is that our standard deviation for this sampling distribution, so our standard deviation of our, we want to go a little subscript here, and that'll be X bar, that'll be our mean. That'll be equal to our population standard deviation divided by the square root of the sample size. So in this case, it was our standard deviation was 9.606. We're going to divide that by the square root of our sample size, which was 5. And that cuts it down almost in half to 4.296. So make sure we can see this. We'll just put it down here below. So this should make sense because we're going from a sample size, each dot was 1 student's height, so a sample size of 1. And we're increasing that sample size to each of these dots that we're going to have here represent a sample of 5. So when we increase our sample size, our sampling distribution will get more narrow. We talked about that a few lessons ago. So let's go to the next page and we'll finish this up with some notes, some important ideas. And it's basically going to be those new means. So we have sampling, those new formulas there. The sampling distribution of, and we want our sample mean here. So sample mean, remember, is X bar, which is X with a line on top of it. And I totally forgot to draw the lines on top of it earlier on the previous page. Let's go back and throw those up there. So we want, this was our mu of X bar and our standard deviation of X bar there. So in order to calculate the sampling distribution of our sample mean, X bar, we're going to use these formulas that we had earlier. So I'm going to go try and copy these formulas. So this says that our sampling distribution mean is going to equal, let's see if that worked. All right. Is going to equal our population mean. So this mu right there, that's our population mean. And then our new standard deviation formula is going to look like this guy, where we're going to take the population standard deviation and divide it by the sample size. And the larger the sample size, the bigger the number we're going to divide by. And we'll end up getting narrower and narrower sampling distribution, smaller variability. So that sigma there, that's our population standard deviation. And then we want to say that n, oops, let's draw. I want to say that n is our sample size. And then a couple things, one more thing mainly. We're going to, again, apply our normal distribution down here, number 3, using z-scores in table A. But the final thing we want to, that we learned in this section here is that A sampling distribution taken from a normal population is also normal. So we can, we were checking n times p before. We don't really have that because we don't have a p, we don't have a proportion of heights of students. We just know that they're means. So this was sample means. We've talked about sample proportions. We've talked about sample counts. And now we're talking about means. So we got a couple formulas here. We're going to wrap all these formulas up together in a nice little bow in another document. You're going to go practice this down here. You're going to calculate the mean and standard deviation given this information and this sample size. You're going to interpret the standard deviation. You can go all the way back up to where we have our interpretation of standard deviation. Our standard deviation interpretation was repeated here. The number of whatever we're talking about typically varies from the mean of, and then our mean by our standard deviation. And then you're going to either go to Statlet, use your table A, use your calculator to calculate the probability that, is this right? Yeah. Oh, no, we already did that one. To calculate the probability of that the mean height of 15 young women is taller than 6.5 inches. And then we can see what we conclude here. So we'll do all that in class. So if you got any questions, ask your teacher. Take care.